the quadratic formula. Looked at a few different ways to find x-intercepts. We started with graphing, actually. That was what you did on your NTI day. Then we did factoring. Then we did the solving by square roots. And now we're going to do quadratic formula. Factoring, for example, does not work all the time. The square root method doesn't work all the time. Quadratic formula does work all of the time, but it can be a little bit more time consuming. So it's a long formula, and it is x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is in the numerator of a fraction, where 2a is in the bottom. So I've got a good song that's to the tune of Pop Goes the Weasel, and after you hear it a few times, it doesn't much leave your brain. So we might, sometimes I put that on repeat until you scream and tell me to stop. Does anything in this formula look familiar?
Yeah. The b squared minus 4ac.
The b squared minus 4ac. Where have we seen that before? Yesterday with the discriminant. What if I cover up that? What about all of that? Negative b over 2a. Where have we seen that before? Finding the x of the vertex. Good. So what we do is we plug in the a, b, and c. Now, based on what your discriminant is, will tell us kind of what our answers look like. If we get a discriminant that is a positive perfect square, then our final answers will be like whole numbers or fractions. They'll be rational, nice, neat numbers. If we get a number that is not a perfect square or that is negative, then our answers are a little bit more complicated. So we'll start with some that we get a perfect square first. So you're going to need, don't write this real big in the middle. Okay, we're going to have like a couple different lines. So starting off, x equals, and then we have negative, what's my b? 12. Plus or minus, both plus or minus, the square root, and then we have b squared, so 12 squared, minus 4, what's my a? 4, and c is negative 40. And then all of that, the whole thing, is over 2 times 4. Now, what you don't do is type this whole thing in your calculator. You're not going to just type it all in. Because if you get a number that is irrational as your discriminant or negative, your calculator is not going to give you the answer the way that we need it. So we have to do it just like a little bit at a time. So the first thing that you're going to do is you're really going to find the discriminant. You're going to type in the numbers under the square root. Don't include the square root, just the numbers underneath. So 12 squared minus 4 times negative 40. And you should get 784. So when I go to my next line, I'm going to put negative 12 plus or minus the square root of 784. all over, and then I can go ahead and do 2 times 4 and put 8 on the bottom. So next what we would do is check to see if 784 is a perfect square. Is it?
Yes.
Yes, it is. So I can replace the square root of 784 with 28. So I would have negative 12 plus or minus 28 over 8. So when we actually have a perfect square that works out nice and neat, that means that we're going to get 2 different answers, and we can just plug it in the calculator from here on out. So alpha y equals, now we have to type it in one time using a plus, another time using a minus. So negative 12 plus 28 over 8 gives me 2. And negative 12 minus 28 over 8 gives me negative 5. So this has x-intercepts at 2 and negative 5. I technically could have factored using this. It may have been faster, but quadratic formula also works. Let's go to number 2. X equals negative, what's my b? Negative 2. So I really have like negative 2 plus or minus square root negative 2 squared minus 4. What's my a? 1. And what's my c? Negative 35. Good. And all of that is over 2 times 1. When you type that in, type in the numbers under the square root to get your discriminant. Make sure that that negative 2 is in parentheses. And you get 144. So back up here, what's negative 2? Positive 2. Plus or minus the square root of 144 over 2. What's the square root of 144? 12. So this is 2 plus or minus 12 over 2. And you get x-intercepts at 7 and negative 5. Are there any questions? Let's go on to number 3. X equals negative, and then my b is negative 2, plus or minus the square root of b squared minus 4 times A, which is 6, times C, which is negative 88. All over 2 times A, which is 6. So when I type in and get my discriminant, I get 2,116. So I have 2 plus or minus the square root of 2116 all over 12. And that is a perfect square. The square root of 2116 is 46. So I have 2 plus or minus 46 over 12. And I get x-intercepts at 4 and negative 11 over 3. Are there any questions? Do number 4. Well, before we get to number 4, let's just think about what is your A? 6. What is your B? There isn't one, so you put 0. If there's no just plain x, your B is 0. And then your C is what? Negative 54. So see what you can do with number 4. Here's number 4. Just be careful. Whenever you have a 0, still make sure you put that in. A lot of people just try to drop it, and that can possibly cause some mistakes somewhere. So make sure you still put the 0 in. Let's go to number 5. And I believe that is 3x squared plus 10x minus 9. So you can go ahead and set it up. Negative B. And I can write, let me write the formula up here for you. So that you don't have to flip back and forth. So it's negative B plus or minus the square root B squared minus 4AC all over 2A. Any questions with getting things plugged in? So we have negative 10 Now under the square root, I'm going to get 208. Is that a perfect square? No. So how we proceed from here is a little bit different. So if we're going to go over to the side, and we're going to simplify the square root of 208. So you need to find the largest perfect square that goes into 208. I'm going to show you a quick way to see the list of perfect squares. If you go into your y equals, type in x squared. We want to see the perfect squares. And then you can look at the table. So second graph will take you to the table. And then you'll want to scroll to see like numbers like 1 through whatever. Those are your perfect squares. Now you might have to flip back and forth to each page, but I'd like to go back here and divide 208 divided by, but that's a quick way to see your numbers. And the largest one is actually 16. 16 times 13 gives me 208. And what do we know that the square root of 16 is? 4. So I can replace the square root of 208 with 4 square root of 13. Now, we're going to check for one more thing, but this is pretty much where you stop. We're not going to type it in the calculator and get a decimal. The only extra thing that we need to do is we look at these 3 numbers. You ignore the one that's under the square root. And see if you can divide all 3 of those numbers by something.
2.
We can divide them all by 2. And that just simplifies it a little bit. -5 plus or minus 2 square root of 13 over 3. And that is our final answer. Are there any questions? Let's look at number 6. Negative, and then I have -6 plus or minus square root of -6 squared minus 4 times 1 times -1. All over 2 times 1. So if you can have this formula memorized, it would help you. And if you can remember, well, I've got the negative b over 2a, and then you've got the square root and the discriminant. If you can remember those individual formulas, you should be able to eventually get the quadratic formula.
Would it matter if you like mix up A and C?
Well, like right here it wouldn't, but if you put -1, your C down here, then yeah, that would mess you up. So you still just try to always get it in that same order. But like if I'm typing it in here and I put the -1 and then the 1, that's not going to change. So we get 6 plus or minus the square root of 40. So we need to take the square root of 40 and split that up. What is the largest perfect square that goes into 40? 20 is not a perfect square. It would have to be 4 and 10. So we have the square root of 4, the square root of 10. And so what is the square root of 4? 2. Square root of 10. And then I look at these 3 numbers. Can I divide them by something? I can divide them by 2. Now, we kind of think of a square root in this sense kind of like a variable. So if you had 1x, do you need to write the 1? Nope. So here I can just put square root of 10. Now when a fraction has a 1 in the denominator, do you need to write that? No. So really, this would be how you would see your answer on a multiple choice test. Now if it's open-ended and you put it over 1 or you put a 1 in front, that's fine. It's not wrong. But just know that's not what it would look like on multiple choice. Any questions? All right, number 7. What's the problem with number 7? It is not equal to 0. So, we've got 3x squared. We need to bring this negative 4x over. So when I bring it over, it becomes a plus 4x. And then the negative 5, when I bring that over, it becomes plus 5.
Did you do that to equal 3x to 3?
You could take the 3x to the right and make it negative. Is that what you're saying?
Yeah, like.
So you could do that. You would have negative 3x squared minus 4x minus 5. I try to avoid having a negative in the front if I can. X equals negative, and then my b is 4, plus or minus the square root of b squared minus 4 times my a times my c all over 2a. So we get negative 4 plus or minus the square root of negative 44 over 6. So this time I'm simplifying a negative square root, which means my answer is going to have a what in it? An I. So when I have a negative under the square root, I'm going to have the square root of negative 1. When you have a negative, it always comes down. And so then I'm looking at 44. What's the largest perfect square that goes into 44? It is 4 and then 11. What is the square root of negative 1? What is the square root of 4? 2. Bring down your square root of 11. And we get negative 4 plus or minus 2i square root of 11 over 6. Can I divide all three of those numbers by something? 2. Yep, I can divide them by 2. I want you to try number 8 on your own. Alright, so you should have started by bringing the 10x over to get 9x squared minus 10x plus 3. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You've got to make sure that you put the right numbers into your formula. Make sure you're looking at your formula really good. So this becomes a positive 10 plus or minus the square root of negative 8. Negative 8 over 18. So I need to go to the side and see what the square root of negative 8 is. So we take out the negative, and then you should have 4 and 2. The only perfect square that goes into 8 is 4. So this is I2 square root of 2. So when I put that together, 2I square root of 2. So you would have 10 plus or minus 2I square root of 2 over 18. And then you can simplify even farther and get 5 plus or minus I square root of 2 over 9. Good job. Are there any specific questions?